Hello, and welcome to the OpenSystem's Media eCast Beyond 2G, migrating a path to LTE for M2M and IoT devices. I'm your moderator, Brandon Lewis, here with today's speakers, Jeff Newman of BEC Technologies. Before we begin, I'd like to introduce our speakers. Our final presenter today is Jeff Newman, VP of Sales for M2M and IoT Solutions at BEC Technologies, Inc. A recognized industry leader in the wireless M2M market, Jeff has more than 2 decades of experience as an early pioneer of the wireless M2M industry. In his current position, Jeff works with key partners and enterprise executives in the technology transition to LTE, helping companies derive new sources of revenue and improve operational efficiencies in key IoT market segments where access to real-time, mission-critical information is required. Some of these segments include public safety, transportation and enterprise, fleet management, industrial automation, and oil and gas. Prior to joining BEC, Jeff was the Senior Vice President of Business Development for Numerex, where he was responsible for defining, developing, and managing new business opportunities for the company's M2M Solutions Group, specifically focusing on enterprise solutions in the asset management market. From 2001 to 2012, Jeff held positions of Chief Strategy Officer and Senior Vice President of Business Development for Infora, where he was responsible for setting corporate strategy and identifying, developing, and managing global new business opportunities for the company's M2M wireless products and software device management solutions. These are sold in the market segments, including security, telematics, home automation, asset management, as well as remote monitoring. Jeff holds a Bachelor's of Science in Electrical Engineering from the University of Arizona and an MBA in Technology Management from the University of Phoenix. He has successfully been involved in a number of startups, including Infora, OmniPoint, Covalink, Vorlon Ventures, and Delta Technologies. With that, I'd like to hand it off to Jeff Newman of BEC Technologies. Jeff, the floor is yours.
Thanks, Brandon. BEC Technologies actually has about a 40-year history of helping develop advanced intelligent routers in the wireline to wireless world. We're located in Plano, Texas, and for about the last 10 years, we've been primarily involved with some of the early LTE deployments in the fixed broadband category and then some of the mobile categories, but primarily focused on helping the rural carriers and now some of the Tier 1 carriers get their early LTE devices deployed. I would say just recently with the push out of the Tier 1 carriers to start to look at LTE for IoT applications, we're starting to see a lot more interest in terms of how you can take LTE and be able to migrate your 2G path to be able to support that kind of capability going forward. So what we're going to talk about in this presentation is really how do you pick the right device architecture to transition from 2G to LTE. Some of the topics have been talked about at a high level before, but we're going to kind of dive down a little bit to some of the detail and give you guys some reference information that you can use to help kind of make that. So in general, LTE is considered the preferred technology for the migration path. It's one of the fastest cellular wireless standard communications activities in history. Mass market expansion of the high-speed wireless networks, data connectivity is a key enabler to kind of the revolution of moving to a pure packet core interface. LTE delivers significant advantages such as higher spectral efficiency, faster data rates, and reduced latency, and ultimately the lower cost of data transmission and a simpler network architecture, which I think is one of the reasons that the carriers on a global basis are really starting to transition and push to this technology. I'm not going to talk a lot about statistics, but I just wanted to throw up a couple of key ones. Interestingly enough, there are 66 carriers in the North American market that have already deployed LTE. So you're starting to see certain vertical segments where carriers have, or where operators have essentially procured their own license. There's more bands in the North American market than just kind of the 5 or 6 that were referenced for the carriers. On a global basis, 450 carriers have committed to deploy by the end of this year, which leads to a significant number of frequency bands internationally. And then of the 3,700 so devices that have been announced today, roughly 800 are what are considered routers, a substantial of which are really being targeted towards the IoT M2M applications. This next slide kind of depicts at a high level the core architectural differences between a 2G network and an LTE network. I'm not going to go through this in great detail, but you guys will hear references like UE and E nodes as opposed to base stations and base station controllers. The key point of emphasis on this chart is really it's a complete movement away from a circuit switch network. So in a lot of M2M applications where you had some, particularly in the SMS world, where you used a lot of the connections to the SMSC, and SMS was the primary fundamental method for communication, whether it's alerts, alarms, or some control over the device. In an LTE network, all of that is controlled through a set of packet interfaces. So it looks a lot like and resembles what's typically done in the hardwired industry today. So there are some considerations that are going to have to be thought of as you move from kind of your 2G implementation and as you move to a pure packet network. What does that mean to you from an application interface perspective? So there's really three types of interfaces that we're going to talk about. They fall into the category of SMS, my packet interface, which is a variety of formats. And then we touched on this a little bit before, but fundamentally, so much of what was done on 2G was built around kind of location services. What's the impact on location services? So I'm not going to drill through this in detail, but in general, SMS is still supported in LTE architecture. The question is which release you're on is what carrier infrastructure do they still have. As you move past release 3GPP release 7, SMS will primarily be supported over IP. So while it doesn't have a lot of impact in the application level, the guys that are doing kind of the detailed modem design and are designing down at the device level need to take into consideration that that is now an IP connection in terms of what the SMS has handled. You can see all the traditional interfaces for a packet interface too. So now you are, your resident TCP/IP, whether it's V.4, V.6. For a lot of the devices that were built in applications, UDP is, still supported. You start to see, less about AT command sets and more about some of the higher order protocols. But I think what's important in this area is you are really moving away from a circuit switch environment into a packet environment. And so for a lot of the legacy applications, it just needs to be kind of thought, how am I going to transition that to, and what does that mean for both my mobile terminal design as well as my application interface? For GPS, AGPS is really kind of the most emphasized location technique with enhanced cell ID and OTDOA as fallback methods. We talked a little bit about antenna considerations. We put this chart together because really what happens is that there's a lot of thought and analysis that kind of needs to go into what antenna you pick. Certainly the band coverage and how many frequencies of bands that you're going to have in your device is a big driver in the antenna configuration. But LTE has a unique feature which basically allows you to determine what the antenna mode is in the device. And so you can see there's essentially 7 modes. Some of them are driven by whether or not the carrier supports it and the mobile device, and whether they can communicate and coordinate between the UE and the E node. But some of them are driven by performance. So you do get some antenna gain as you move from a single antenna to a diversity-based antenna. You can see that you can get to some of what was considered the MIMO capabilities, but that's really user-defined antenna, some geospacing stuff. So from a design perspective, while cost is certainly an issue, depending upon which frequency bands you're in and depending upon the transmissions of speeds that you're offering, you have the ability to actually get some system gain moving from a 1-antenna solution to a 2-antenna solution. I think it's important to note that some of the carriers, and it depends, are allowing single antenna solutions with some of the Cat 1 stuff and in fixed applications. But really, as you guys decide to implement your antenna design, you want to do a map between the category of device that you're doing as well as the application and take a look at kind of the whole coverage scenario and see whether or not the cost difference of designing a single antenna versus the diversity-based antenna is worth the effort. This next area that we're going to talk about is one that's been really in the news a lot, and I think the latest analysis we saw said that there are some 70% of M devices out there are susceptible to attack. And while in the 2G network that wasn't necessarily such a big deal because GSM encryption, and in a lot of ways it was kind of proprietary protocols that were done between the devices, wasn't an issue. As you get to a more full IP-based environment, this is becoming a bigger issue and concern in the market. So LTE and particularly the guys that are doing modem designs in this space, does offer the opportunity to put in quite a bit of capability. Essentially, since you're on a packet-based network, you can put in, virtual LANs, VPNs. You can start to do some filtering, firewall protection. But all of that kind of comes built into the overall system architecture, and a lot of the modems and chipsets that are being put up today have this capability built in, and you're not going to pay a more substantial price point for it at the underlying level. But it's just something to consider as you relay out and design your next generation solutions is, how do I want to handle security and what do I want the position to be with respect to being a full IP network? We talked a little bit about device certification. This chart highlights what our experience has been deploying the last series of devices that we've done. I think it comes as a little bit of shock to people that deploy their first LTE devices, that the cost increase from what was typically done with 2G and even 3G. A lot of that is driven by the fact that you have multiple band coverage with LTE. There's additional test cases. There is fallback if you do it to 3G and 2G, so there is regression testing that's done in those things. But fundamentally, you can see the range of costs associated with this. There is a lot of dialogue around the fact that as we move to Cat 1 devices in 2016 and 2017, particularly Cat 1 devices that do not have fallback to 3G or 2G, that you'll see those certification prices come down to something that's more reasonable. But I think it's important to note that, it is a brand new radio. It is a brand new protocol. In a lot of cases, it's new antenna designs. And so typically in your budgeting and your release of products, you want to take into account that your first set of certification costs are going to probably be more than what you're used to seeing today, which I think goes back to making sure as you understand how you're going to lay your devices out and the roadmap that you're going to use to move towards whether it's Cat 1 or Cat M long term, you understand how to basically get your devices out there and how you're going to support them on not only a North American level but on a global level. So this chart highlights kind of the move from what today is a lot of Cat 3, Cat 4 devices, eventually going to Cat 6. You can see the push of the slide. And so I don't know if people can see that or not, but there it is. Okay. So this shows the map of what we consider kind of the relevant categories of LTE. Today, most of the devices that are on the market today are Cat 3 and Cat 4. There's some Cat 6 stuff that's coming out, but it's really driven towards high-speed video connections. Cat 1 is what all of the carriers, at least in the North American market, are talking about, and it's kind of the first step towards really normalizing the device costs. And you can see, that, the difference in speed and being able to limit, kind of the capabilities of the device is one area that the carriers are using to help get the cost down. The other is that in some of the Cat 1 deployments, the carriers may not require fallback to 2G and 3G. So you need to think about that in terms of coverage map and location and risk associated with that. But when you no longer have the fallback to 3G and 2G, you'll see the certification and device costs come down quite a bit. There's been some speculation in the market of whether or not Cat 0 will really get realized or whether the market will move to Cat M. I think from a standpoint, certainly most of the very low bandwidth 2G applications that are out there today would certainly fit in the bandwidth requirements for Cat M. It's really a function of, where does the volume occur and how fast does the volume occur. But you can see on this roadmap that you could be doing some Cat 3 deployments today to get a feel for, how does the radio performance work, how does the antenna performance work, how's my coverage, get my APIs, all of my device management built in, and then have a quick path to Cat 1 and then eventually to Cat M, and you would continue to come down the cost curve in those areas. And you can see over the timeline that Cat M, at least through several of the major carriers, should be ready and available by the later part of 2016, and certainly in 2018 we're going to start to see some Cat M stuff. So a couple of things that BEC has done in this place, in the marketplace over the last 6 years of deploying LTE to kind of help us and help our customers and partners understand is we built the cloud connectivity services, which is really around validating the performance of the UE device. And so today, through our system, we can help customers understand what does the network really look like, what signal strength, what towers are you camped onto, what kind of capacity you're starting to use, how the devices perform, as well as all of the remote programming capability, whether it's IP6 configuration, VPN configuration, the ability to reload firmware. But fundamentally, the majority of the capability that we've built in and what's been most beneficial to our customer base is the ability to kind of look at traffic and bandwidth and network performance on the device. And so it's allowed a lot of our customers in their applications to get devices deployed, get the applications enabled without making the volume commitment and starting to see how well things perform, and then allow that to help them make some decisions in their antenna designs and their deployment scenarios. But it's been a quick tool and ability to get people out in the field and get them testing and actually using the LTE networks. So from our perspective, we see the migration on a global level. I mean, we deal with this every day. Customers and new competitors and new entrants into the market that are trying to use LTE as a way to get into the marketplace. Our experience over the last 6 years has told us that you can really transition to LTE with confidence. I mean, the capability of the network is extremely strong. The types of products that we do today, our experience has been that you can make an incredibly secure system, scalable, robust. What works on the LTE networks in the North American market from an application perspective works in other parts of the world without a lot of changes to either the device or the back-end application. You really, if you start to look at the capabilities of a true packet-based system, you can start to see how you can add and enhance value, whether it's the ability to have quicker connection times, the ability to collect more data, but there's just some things that you can do in a packet-based network that were a little more difficult in the circuit switch solution. So we would highly encourage and recommend companies that, you certainly want to get started today, at least at a level of starting to test and integrate your application into the LTE network, and then make the decisions that kind of fit into your timeline and your carrier selection, as well as what cost points you need to move to volume. But there's absolutely no reason why you wouldn't get started today and starting to understand and work with LTE transition in your application. And with that, I'll kick it back to Brandon for Q&A.
Great. Thanks, Jeff. As Jeff pointed out, that brings us into the Q&A portion. Can you, Jeff, start us off with, I know you touched on it during your presentation, with a little bit of discussion about the security issues that are facing M2M and IoT devices using LTE. And then what's the best way to go about handling those? Do you think it's trying to build something in-house, outsourcing it to a third party? What are your suggestions there? Big question.
Yeah, so, the security element has been well reported over the last year or so with the vehicles that have been hacked. And so, with LTE, you're on a true packet network. So, once you assign pure IP addresses, your end devices are at the same risk that your computers are and your home computers are in your home, right? I mean, it's a true IP system. So there's a couple ways to handle that. I mean, you can build that all kind of through firewall and security and encryption on the device's perspective, and you can do that with the same types of things that you do in your IT infrastructure world. The price you pay for that, right, is you have to kind of go in and do that and manage each device separately. There are a number of third parties out there today that are starting to build in kind of encryption software with keys that are more what they would call M2M or IoT keys, which is a small keying sequence that you have to be able to pass back and forth. That eliminates some of the overhead, but fundamentally, once you're on a packet-based network, you assume the same risk that you do with any of your devices. And while that may not sound like a big deal, the reality is it's not so much about stealing the information from the device. Is it about disrupting the operation of the device and impacting the performance of the business? So you can imagine a scenario where either devices basically get tried to reset or get sent messages they can't understand, or get, hammered, or from a carrier perspective, they get denial of service. So it's more about disrupting the business as it is about stealing the information off the machine. Excellent. Thank you, Brandon.
Here's another one for you, Jeff. How do you, and this is a great question in this context, how do you avoid kitchen sink sort of scenario, and Jerry, you'll probably be able to add some flavor into this as well, where you're adding 2G, 3G, 4G support aside from 2G support in the U.S. Do international trends suggest 4G support at some time in the future with 2G fallback? What's your take?
So I'll start off, and Jaron can jump in. But in general, the North American market, particularly U.S., is a little different than the rest of the world because of the requirement to get off of 2G. At least from what we see in the rest of the world, one of kind of the two main bands for 2G, whether it's the 900 or 1800, is still being allocated to 2G, and the refarming is occurring on the 1800 bands. Now, we're seeing lots of carriers add additional bands to try and create classes of services. And so they may create a class of service for public safety, or they may create one for fleet or, digital signage, things where the bandwidth is, but at least in most of what we're seeing in the rest of the world, there's a longer-term commitment to 2G. So I think the question becomes, in the transition in the U.S. market, is do you really need, when you queue up your product configurations, do you need a product that falls back to 2G, 3G, and 2G for every single possible band that you can ship to, or do you build a modular solution that allows you to have kind of one solution for Europe, which is either 2G-centric and maybe an upgrade path to LTE, or an LTE path that falls back to 2G? But clearly the U.S. market has a lot different challenges and requirements than what we're seeing internationally. Thanks, Brandon.
Great. Unfortunately, that brings us to the end of our time today, and we at Open Systems Media, BEC Technologies, the Mori Corporation, and CORE would also like to thank you, the audience, for attending today. Thanks again for attending, and have a great day.